share my screen. So we have stopped. We were talking about the addressing mode, and now we know what's the meaning of addressing mode, right? All of us, we know this. We know what the meaning of addressing mode, and we have started with the simple one, register addressing mode, embedded addressing mode, right? We talk about these two. Now, and let me just review them. In embedded, we use a constant. We know that the instruction has many parts. We have the opcode part and we have the operands part, right? And the operands we may have two and we may have one, depend on the instruction. So let me focus on the move instruction. In the move, we have two operands, right? Because the point of this, I'm copying something to another, right? From a store to another store. Now I have a source and I have a destination. In a register, both they should be what? Registers, either 16 bits register or 8 bits register. In the constant or the embedded addressing mode, we have 1 minute, guys, just 1 minute. Okay, so this is for register. Constant, it should be part, like when I write, for example, move ax comma 456 hex. So this part, the source part, should be what? Should be a constant. So anytime you see this part is a constant, you know that this is what? Embedded addressing mode. So again, the addressing mode, how do I access, or what's the type of these, okay, operands? They are register, they are memory, they are what exactly? Now, you can ask, why do I have all these types? It depends on what's the application you are running, and you'll understand this once we finish all of them. Okay, so this is what we have studied before. Now, in this lecture, we are going to focus on memory addressing modes. We have 5 types, mainly talking about how I access the memory in different ways. So something called direct addressing mode, and we already started this in the lab. We have something called register indirect addressing mode. We have something called based addressing mode, index addressing mode, and base index. Don't worry, they are really easy. Once you got the first one, you can get the rest easily. Okay, so let me start by the direct addressing mode. Okay, in the direct additive mode, remember we have how we access the memory using what? How do I access the memory? What do I need? Exactly, I need, yes, I need address. So this is the point. How can I get these addresses? And we know that, let's talk about the physical address. The physical address is two parts, right? Two parts. What are these parts? How can I get the physical address? Let me, I know that you studied this. Exactly, 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 yes. So, yes, so I'm going to access the memory, either if I'm direct, whatever, what is the addressing mode time, I'm going to access through the physical address. If I know the address, I can get the content that I need, right? So this is what. Now, sometimes, like, we will not use mainly when I write the instruction, okay, to get any content from the memory or send the content from memory. I'm not going to use the whole physical address. It depends. Sometimes I'll do this, sometimes I'll use the logical address, and sometimes I'll just use the offset. Let's see how. So let me come here. Now we know that if I'm using direct addressing mode, how can I know that this is a memory from the instruction? Like here I have one example, move AX, then I have square brackets, then I have a constant value. Now forget about the addressing mode. Now once you look for this and you see these square brackets, you will understand that you are dealing with memory. Okay, that means I need to go to the memory, check the content there, or get the content from the memory. So anytime you see this square brackets, you have to know that I'm dealing with memory type. Now go back to the direct. Now for the direct, how can I know it's direct? You will give it as a constant value. You will give the address by yourself. You know where is the data, okay, or where is it's pointed in the memory, and I'll give it as a constant. Let me see if you have questions. Yes, Abdulrahman. Yes, yes. It's not the lab at all, yeah, Abdulrahman. Exactly. It's not the lab. And I already mentioned this. You are right. I'll talk about this. Just give me time. So focus now about 8086. Remember, every microprocessor has its own structure, its own architecture, and even when we deal with the software, when we deal practical, sometimes the things are different. However, it's just a little difference. I'll talk about this. Now let's focus about the theory part. Now in the theory part, as I said, once you see square, okay, brackets, you know this is a memory. Now, what's this exactly? I wrote the offset directly here. I wrote 1, 2, 3, 4. This is not a constant value, okay? This is not a constant value. Here I'm referring to the data, okay, location. What is exactly in the memory? So 1, 2, 3, 4. I need to go to which segment? What do you think? Data segment, code segment, stack segment. What do you think? I'm going to go where? By default, it's not mentioned here. Like how do I write the address? I'm going to specify the segment, then a colon with the offset. This is how we write it, okay? We specify which segment, because remember, we have many segments. We have data segment, we have code segment, we have the extra, we have the stack. So if I did not specify it in this way, which means go to the data segment, offset 1, 2, 3, 4. If I did not write it in this way, that means by default it will be data segment. Deal? Okay? Uh, so anytime you saw square, you know that this is memory. If it's not mentioned here, okay, you go directly to the data segment. If the data segment is not mentioned, you know it's data segment. If I wrote this, let me know. I need to point to the code segment and go to that offset. If I wrote it in this, okay, I need to go to the stack segment, go to the offset 1, 2, 3, 4, and just for example get the content there. So guys, this is not a constant, okay? This is a memory address, okay? So this is the part. Once you see a constant number with the brackets, you know that the addressing mode is a direct, okay? Now here I have another example, like here move AX. Now here is not data segment, it's code segment, because I have specified this by a prefix. I call this a prefix, which will tell me from which part of the memory do I go to, the code segment or data segment. If it's not mentioned, by default it's data segment. Okay, now how things happened exactly. Now let's understand as a memory structure, or as I'm talking about now about the code segments. Now I said move CX 1, 2, 3, 4. What's the meaning of this? Can anyone? The meaning of this, I'll go where? I'll go to the data segment. Okay, offset 1, 2, 3, 4. The content there, how many bytes I'm going to take from there? What do you think? How many bytes I'm going to take from the memory? How many bytes? Y2, yes, you are right. Why 2 bytes? Why Umama? Hissa. Yes, why? Yes, it depends on the size of the destination. Like if I change this to, for example, CL, how many bytes I'm going to take? I'm going to take 1 byte. Yes. Now we know that these instructions are written, but okay, so this is the instruction. Now I'm in the code segment. What are these letters here? What are these letters in the code segments? What are these? These are the content? No, of course not, right? What are these letters? Instruction. And what do you mean by instruction? No, this is the instruction, right? This is the instruction. What are these? Mhm. Exactly, Maha. That translation. Now remember, when we wrote the instruction, and when we wrote the instruction, right, the assembler will translate this, right? Like what is move? Okay, what is CX? What is 1, 2, 3, 4? We need to translate this to the machine code, right? We refer it to as object code. Every instruction has an object node. Now, so how do I know this? For example, in the lab we use 8386. Here in the theory we use 8086. Of course, we don't memorize these. We don't memorize the object code or the translation of each assembly instruction. Of course, there is a manual and we follow the manual of this. So A1, 0E, 3, 4, 12, these are the object codes or the translation for the move instruction. Now you'll ask me, now every time is it 4 bytes? No, every instruction has an object code. If this instruction is using with I'm using this instruction with registers, it will has an object code. If I'm using this instruction register and constant, it will has another object code. If I'm using this instruction with register and memory, it has a different instruction object code. If I'm using this instruction with for example, memory elements 16 bits or 8 bits, I'll have also different object code. So not only the instruction, the type of appearance, it will affect my object code. Remember, we need to turn this to machine code so the microprocessor can execute. Otherwise, it will be what? Nothing. Microprocessor will not understand this. So remember, every instruction I converted to object to depend on instruction. For example, in move, I may have 2 bytes, I may have 4 bytes, it depends. Now, what is this? What is this? What is this? What do I call this part here? So we know that this is the translation. What are these? Exactly, these are the physical code. So here I'm pointing when I execute the instruction. Of course, there's a pointer will show me. Okay, there is a pointer will show me which instruction I'm going to execute. Now, which part here am? This is the IB. IB is will show me. Okay, um, or sometimes we refer to it as the program counter. IB will show me, okay, which instruction I'm going to execute next. So here I'm executing the instruction. What do you think? It should give me the address of what? Assume here I have another instruction, another move. Okay, so the IB should okay point to the another to the next instruction that I'm going to execute. So IB should point here 0100. Okay, so this is the IB. It should point for me here. Okay, so be careful, the IP should point to the next instruction. تمام? So I know that I have an instruction and I know I have to translate this to object code. Every instruction taking bytes depend on the type of the instruction, depend on the type of the appearance, depend on the size, and I have a pointer that point to the next instruction that I'm going to execute. The instruction, Muhammad, yes, as I said, no, don't connect the size of this. Okay, don't connect the size. That does not mean, Muhammad, if I have here 2 bytes, this should be 2 bytes. Okay, if we have time, I will show you the architecture of one of the microprocessor. You will understand me. No, this does not mean if this is 2 bytes, I have to the object code of the instruction should be 2 bytes. Okay, and I will show you example of different instruction at the end of the lab. No, that does not depend on this. Yes, it affects, but this does not. If this is 2 byte, that does not mean that this is 2 bytes. I have here 2 bytes. Okay. Now this is for the direct address mode. I'll give the address, okay, or the offset as a constant value, which means go to the data segment offset 1234 and see get the content, then save it in CX. تمام? So this is what will happen exactly here. Nothing here mentioned that mean I'm data segment. Clear this? And the bus takes only 2 bytes at a time. Does that mean it takes 2 cycles to read the full instruction? Now, it depends how many cycles I'm executing each time, right? How many instruction in each cycle. So, okay, so you are comparing this how many times I'm even. It's okay. We may have many cycles in order to execute one instruction. What's the problem of this, right? I may have, so this is okay. Got the hint? So I may have, for example, um, depend on how many cycles I need in order to execute one instruction. This is different. This is talking about the speed. I'm talking now the object code and the save in the memory. Okay. Yeah. Ali, Dr. Ali here. They say 2 bytes. Okay, okay, okay. Now, so this is for the direct addressing mode. Clear? So anytime you see it's a constant, okay? What is it? It's a constant. You know that this is what a direct. Please don't consider this. That does not mean I'm going to save here 1 2 3 4. No, I'm going to go to the address data segment offset 1 2 3 4, give the content and save it in CX. Tamam? Is that clear? So anytime the address is as constant, you know that this is a direct addressing mode. Any question regarding this? Clear? Okay. Okay. Now, Dr. Ali is explaining for you. Yeah, Sarah and Hind. Number of bytes once indicate how many cycles in fetch. Yes. Yeah. Okay. Now the second addressing mode that we have to go is called register indirect addressing mode. Here, okay, we'll use something in the middle, something between, okay. I'll not get the, it's not a fix here. The address is not a constant. It's not a fixed value, okay. I'm going to save the address in a register. Now remember, anytime I see a square brackets, I know that this is a memory type. Memory of SI. This is means what? Remember, this means I'll go to the data segment, right? Okay, offset SI, right? This is the address. It's written in this way, unless you specify another prefix like CS or SS. Now by default, it's data segment. Now here I'm saving, okay, I'm saving the address in another register. Okay, it's not constant, it's not a fixed value. Okay, so to fetch this instruction is doing 2 trips. Yes, yes, not all instructions take the same number of cycles. Hence, is that clear? Dr. Ali is trying to explain this point for you, or I think Sarah. Depend on the instruction. Six byte, then fetch will take 3 cycles and so on. Yes. So now based on this, maybe Dr. Ali can correct me. Now here I have 4 byte. That means how many cycles based on Dr. Ali explanation? It means I'll take 2 cycles. Yes. Thank you, doctor. Yes, exactly. We got the point. So now we can see other example, different bytes, and we can see how many cycles it will take. Thank you, doctor. Okay, tamam. Okay. Everything now clear about the direct. Now for the indirect, okay, it's not a fix, it's not constant. I'm going to use, okay, I'm going to save my address in a register. So when you see a register with a square brackets, you know that this is not direct, it's not a constant. I'm saving the address in a register. So that means goes to the data segment, offset, this is the address exactly, of SI, copy the content and save it in AX. Now how many bytes I'm taking depend on the destination. Since this is 2 bytes, I'm going to go to the memory and get 2 bytes. Okay, so this is what here the slide is explaining. I'm going to take the offset from a register, maybe SI, maybe DI, BX, okay, BB, and so on. Now here is giving you there are specific registers that I can use in order to hold or carry the offset. Like here, for example, we can use SI, it's written here. We can use BX, we can use BB, we can use SI and DI. So anytime you want to save the offset in one of this. Yes, doctor. Yes, doctor. Just went. Dr. Ali is trying to explain something for you. When I try to start. Muhammad, do you mean Muhammad, do you mean on Visual Studio? Yeah. Here, doctor? Okay. Which register, doctor, you mean? I don't get the point. Okay, DS is 0200. Okay. Okay, I got your point. Okay, now he's meaning we need to execute the instruction. So let me execute the instruction with you. I got your point. Now this is the instruction. Let's do it step by step. I got your point, Dr. Ali. So this is move CX. Okay, 1, 2, 3, 4. Can you give me the physical address for this? Okay, I want the physical address for 1, 2, 3, 4. It's what exactly? When I say 1, 2, 3, 4, give me the physical of this. Yeah, I'll do it step by step, Doctor. Yes, I got you. Yes, Doctor. So let's start first by executing the instruction. Can you can you give me the physical address for this? 0100. Yes, yes, ma'am. Yeah, this is for CSIB. Yes, +0. Yes. Remember that IB is pointing to which instruction I'm going to execute next. Right? So I'm executing, yeah, this instruction. Okay, now let's execute the instruction itself. Okay, please follow Dr. Ali. He's trying to explain for you. Now, how can we execute the instruction? Yes, 2 cycles. which segment now we are going to deal with? Now we fetch, right? We know. Okay. Now to execute the instruction, where do I should go? Yeah. To which sorry, to which segment? Okay. Data segment, yes. Exactly. Which physical address? Can you give me the address? Yes, DS1234. Okay. So go to that address. Can you calculate this for me? DS1234 and give me the number. Now, Maha, we want to execute, right? We want to execute this instruction. Where do I have to go? How can I check the execution of this instruction? How can I know what will happen to the CX, right? Remember, I'm going to the memory, taking 2 bytes from the memory, and I'm saving them in CX. So which address I need to go? So this is giving me, right? It's referring to me to the address. So to which address I need to go? Yeah, the microprocessor now it's making the execution. Yeah, this is the data segment. I'll start from here. This is the data segment. Because if refer to data segment here, it's 0200, right? We add 0 for the physical. Yes. Yes. Yeah, and this is where exactly? Is it this one or this one or this one? It's where exactly? So we know that this is data segment. Then what? Yes, Omar, exactly. Yes, exactly. So Dr. Ali is trying that, going step by step, that first we'll go to the data segment, okay, which is this part here. And I know this from the DS register. Then I'll start, okay, getting the physical address, which is DS. Okay, I'll just add the address of DS, add to 0 plus the offset 1234 to reach to this point. So this is what Dr. Ali is trying, going step by step. Now, Doctor, yes, what is the direction of copying? No, Hind, we are not copying. Look to the instruction. We are going to this address, okay? This is your source. This part is the source operand. We go to the memory and take the content and save it in CX, okay? So we are taking from the memory and save it in the CX, the opposite. Yeah, Dr. Ali. Yes, Tamara. Yes, yes. Yes, Omar, exactly. So destination is CX. So I'll go to that memory address 323. Yeah, if you calculate this, it will be this part here. Copy the content here to CX. What is the value of CX? Can you write for me the value of CX? Based on this, can you write for me the value of Cx? It will be what? Of course, I'll not change the memory. I will change the Cx, right? Because I'm going to save here. This is my destination. Exactly, FEED, yes. Yeah, we talk about this, Dr. Ali, yeah. They will take two. Yeah, Dr. Ali is asking how many bytes to read from memory to copy to CX. So we said this should be depend on the destination side. If I'm writing here 2 bytes, it will be 2 bytes. If I'm, for example, if I did this, what will be the value? And instead of CX, if I change this to CL, of course, when I change the instruction, this will change. Be careful. I'm just giving example. Okay, let me see. Yeah, they in which order? Yeah. Dr. Ali is asking in which order. Remember, this is the lower to the lower part, the higher to the higher part. Little Indian, yes. Yes. تمام دكتور؟ تمام. Okay. So again, just a revision, and Dr. Ali may say if I'm wrong. So first step, I'm fetching, understanding the instructions, and this is, then I'll go to the data segment. So I want first to the code segment, okay? Then I want to data segment, and then I check the content, okay? The execution, I did the execution. So this is what was Dr. Ali going step by step. What other changes will happen to micro? Yes. Now, which other register will be changed? So CX, it will be modified with the value. Then what? What's, yeah, IB, because IB should point. Yeah, doctor, take your time. Of course, you are right. Take your time. Yeah. Yes, the IB, because IB should point to the next instruction. Okay. So if I have more instruction, for example, it will be pointed here. Okay, doctor. Any other things, doctor? Should now prepare. Yes. Prepare the microprocessor to fetch or get the next instruction from the code segment, because all the instruction will be saved in the code segment. Okay, Tamara Engine, can you please repeat the part how we know 03? Yes. No, this is not the value. Okay, I'll talk about this, Tamara. Just, I'll show it to you again. Yes, Hind, we go to the next one. Dr. Ali is trying to explain how can we know that this instruction is 4 bytes to increment IB by 4? depends on the object codes, right, doctor? This is what I... It's from here. How can we know that it's taking 4 bytes? This is the question that Dr. Ali is trying to ask. If, yes. So for example here, yeah, there's a constant. It will be shown as an object code here. Okay. So that's why you see here 1, 2, 3, 4. So if even like if I this is a constant, I wrote a constant here, it will be shown here part of the instruction object codes, which is the end of the instruction, as Dr. Ali Mercy mentioned. Now the IB will be increment in the same instruction. Yes, we have to refer to the architecture manual that we are using in order to know each instruction taking how many bytes and what is the object code, and even the size will affect the object codes. Yes, and we will see examples. Yeah, so because of the order, 34 will be saved here, and 1, 2, it will be saved here. Yes. Is that clear? Like Dr. Ali, he's trying to say, if the instruction has some constant, I can know that I can know some bias of the object codes. So for example, here I have 1, 2, 3, 4. Okay, this is a constant part. It will be shown at the end of the code. Okay, so 3, 4 is the lower part. It's saved here, and 1, 2 it's saved here. So if the instruction has any constant part, it will appear in the object code. Got it? Please feel free to ask if there is any point is not clear for you. تمام. Special case for what, Muhammad? No. Anytime you have a constant in your instruction, it will be shown in the object code. Let me show you. Maybe I have here. Before we start, we were not planning to show you this. Okay. Let me show you this, okay? I'll show you example of this. Can you see this here? Now here I have an instruction move AX15. I'll talk about this file, and already we talk about this in the lab. It's the listing file. However, that file, just check here. For example, I have move AX15. That file will show me the object code. Now see, 15 is a constant value. Now this is in decimal. It's showing you here. Can you see F? So yeah, part of the object code, you are going to see the constant that you are using in your instruction. This is the point. Okay, so here I'm using 1, 2, 3, 4 as constant number. It will be shown in the object codes. Yeah. Yes. If there is no constant, like if for example instead of this I have bx, okay, for example, we cannot know this because as I said we don't memorize them. We have to refer to the manual and understand how many bytes it will take. So if there is no constant, we cannot have like we cannot know that what are these, they will be what exactly. But if there is a constant, like in this example here, I can know that I have at least here I have 2 bytes for the constant, because this part will be shown here. Done, Dr. Ali? Yes, yes, we will have many examples, Maha. You'll have many examples. Okay, done. Let me just go through the additive modes. But is it clear for you? And now one of you asked me, how did we reach here? How did we reach to 0, 3, 2, 3, 4? Now this is in the execution part. I think Tamara. Yeah. Now remember, Tamara, what's here? This means go to the memory, okay? To that memory address, get 2 bytes because the destination is 2 bytes, and save them in CX. So how did I calculate this? So I took this number, which is the offset part. Remember, this is what? It's DS. Thank you, Doctor. CS 1, 2, 3, 4 hex, right? Tamara, are you here? You asked me this question. So how can we get the physical address, Tamara? What we do, right? We go here, remember, DS it's saved here. It's written here 0200. So I'm just calculating the physical address. So I'll come here, say 0200. Of course, we need to add 0 plus 1234. Exactly, yeah, Tamara. Once you do this, you are calculating the physical address, which is this part here. So I want to the memory of this. Now I'll take the content. What are the contents? FEED. I'll save FEED in CX. So CX at the end should have FEED. This is the execution. Clear, ya Tamara, for you? Okay, alhamdulillah. Now the second part, or the second addressing mode, is the indirect. Now indirect means what? I'm going to save the offset in one of the registers. We have 4 main registers. I'm going to use them, which are BX, BB, SI, and DI. Okay, so if I wrote SI here, that means I'm going to go to the data segment. As I said, if you wrote it like this format, okay, that this is acceptable. If you did not write here which segment, remember, because we need to refer or point to the physical address. So if it's not written, you know that it's DS. Now some register like BB, for example, okay, like BB, you know that by default is what? I'm pointing to the stack segment. BX, by default, I'm pointing to the data segment. So anytime you want to save your offset, okay, you can use one of these registers, BX, BB, SI, and DI. So here not I'm dealing directly as a fixed value like indirect. No, save, okay, the offset in one of the register, okay, this is the step here. So I'm not dealing with constant or fixed value. I'm saving the offset in one of the register. What are these registers? BX, BB, SI, and DI. But I have to know when I use them, I'm pointing or I'm using which segment. So if you use here, for example, SI, that means data segment. If I use BX, by default, I'm using the data segment as well. If I'm using BB, that means I'm using the stack segment. If you don't want the stack segment, you want another segment, you have to add it by yourself. So DS, you have to add the prefix, okay? And here also we have another example. We know that the SI by default is data segment. So if I want to change this, I need to add the prefix for the segment, SSSI. At that point, I'm pointing to the correct, okay, address. Is that clear? Just remember this. BB, the default segment is what? Stack. BX, the default is data segment. If you want to change, if you want to use another segment, you have to add the prefix by yourself. Clear, guys? let's I want to show this just to show you, like indirect, I just directly used the direct value, but indirect, save the address in the register, then go to the memory. So I'm doing this in two steps, not directly. This is the difference. So like here I have add AL0301, this is direct addressing mode. Here I have move AXBX. No, this is indirect because I saved first the register in BX. And when I use BX, I'm pointing to the data segment. Clear? We know the difference? The only difference that I'm saving this number in one of the register. Instruction memory, here no. Save the address in the register, then go to the memory. Ma'am? Now let's take example here. Now here I have move AXSI. Okay, let's do it together. Now what is the first step? Let's just follow what Dr. Ali did in the last one. Now here, once I know that there is a brackets and I'm using a register, I know this is what? Is it direct or indirect? Up to the instruction, move AX, comma, brackets is I. This is direct or indirect? تمام. We know it's indirect because it's saved in one of the registers. Now what is the next step? I have to do what? Remember, we are here in which part? Data segment or code segment? I need to fetch the instruction, right? I am in code segment. To check the instruction, we go to the code segment because we know all the instructions are saved in code segment. Now, how many bytes this instruction is taking? حصة, هند, مها, مها. How many bytes? Exactly. How many cycles? See, I'm studying with you. I'm refreshing. Yes, one, yes. Yeah, because it has 2 bytes. Alhamdulillah Rabbil Alamin. Type. Now, we know now it's taking 2 bytes, the number of cycles. We went to the code segment. Okay, this is the object. Can we know this object code? Can anyone know? Or we have to refer to the manual? Dr. Ali. Yes, exactly. And because there is no constant, I cannot type. Now, what next? Where do I have to go? What is the next step? I make fetching, I had the translation, I understand the object codes. Where do I have now to go? Yes. So which part? Which part I need to go? Give me the physical address. Let's be professional. Where do I have to go? Remember, the data segment is saved in 0200, right? In data segment, I have 0200. So now I am pointing here, right? This is the data segment for me. So this is step number. Yes. Now we need to calculate the DS. Remember, by default, SIDIBX. By default, this is referred to the data segment. Only the BB, we use it for stack segment. So this is actually DSSI. Do I know what is in SI? I'll go to the SI register, right? So exactly it's the same thing, but the only difference that here I use a register instead a constant value. So I'll do the calculation for this, and when we do the calculation, now Tamara, can you do the calculation for this? DSSI, it will be where? Exactly, Hissa, exactly, Tamara. Yes, Hint, you are right. So now I'm going to get the content and save it in CX. In which order? Remember the order, please. Now, which register? Is it AX? It's not CX, sorry, it's AX now. And remember the order, yes. Yes, mashallah, you are really good. Now, what about the instruction pointer? Remember, we have, what about the IP? What will be the new IP if I have more instruction? Give me the new IP. Give me the new IP. Or even, oh, yes, exactly, guys. So I took 2 bytes, so that will be increment by 20002. Yes. Thank you. Yes. Any points, doctor? Are you okay now? So we know the difference between direct and indirect. Okay, so please, if you miss a point, let me know. So this is for the indirect. Now the rest are really easy. We have, let me see before. Okay, now the rest are really easy. Okay, the only difference now we will do, the rest is little bit, okay, like the indirect. But when I talk about the base addressing mode, okay, I need to use a specific type of registers. Now when I say base addressing mode, I'll use the base registers. What are the base registers? Do you know them? What are the base registers? We have BX and we have BB. These are two, let me write them here, BX and BB. So once you see one of them is used with another condition, which I'm going to specify now, we'll do the same thing. I'll save my offset similar to the steps in indirect. I'll save my offset in one of the register type, but with base, I have to use base registers. Like, can I use, for example, SI here? We know that we call SI and DI, we call them index register. BX, BB, we call them base registers, okay? So BX, BB are best. So if I'm using base addressing mode, can I save my offset, for example, in SI or DI, or only with BX and BB? Exactly. So when you deal with base register, we have to deal only with this or only this stuff. Why I'm going to save my offset in BX and BB. If we go back here to this instruction, and instead of SI, I will just use either BX or BB. Okay, the same. Now, what other thing I have to add? Okay, slide. What other thing I have to add? Just a minute, I lost the slide. Okay, I have to add something called displacement, okay, value. Now, where do I use this type of addressing mode? Now, let me talk about a little bit like a programming language or high programming language like C++. Remember when we deal with arrays? Arrays. We have first to point to the array, and sometimes you move elements. Like if I say that I have array A0, okay, then for any reason, okay, I ask you, give me the element at position 6 or position 5. So what you say? You say it's 0, right? 0 plus 5, right? This is what we do, right? So sometimes I need to do this in even in assembly language. Sometimes when we do matrix multiplication or array multiplication, we want to refer to the other elements in the same address. So here I have the address pointed to A0 for example, the array. Okay, and then I need to move to other elements. So when I want to move to other elements, I just add a displacement value or a constant value, which means just I am in the same address but just move between the position, go to fifth element or sixth element. So I used plus 5. So this is the point here. Now can I use, so anytime you use paste, you have to use what? A displacement value. You have to add to this a relative value or a constant value. Okay, let me show you this. Yes. So Dr. Ali, he was saying, like, let me show you example, okay? Let me show you example so you directly, like here, look to this here. Uh, okay, look to this here. Now, when I say, okay, move, I have this, I'll copy this here, okay? Let's do it step by step. Let me show the instruction clearly. So here I'm using based addressing mode. I forgot the part. Sorry, I forgot the part. Okay, so here I'm using one of the base register them and adding a constant. Okay, I'm adding a constant. So what Dr. Ali, he's saying that we are merging two at the same time. This means what? This means what? When I write it in this format, this means what? Go to I know that this is a memory, right? This is a memory, but this is equal to what? Which memory do I go here? I have offset saved in bx, then I have plus a constant, a displacement value. So when you have one of the base register plus a constant value, we know that this is what? A base addressing mode, base register addressing mode. So how do I get the physical address of this? Remember, when I use bx, bx refer to which segment? Refer to ds, right? Bx, which means I'm in data segment. But how do I calculate? I'm going to know what's in bx and add a constant value to that offset, which is 1, 2, 3, 4. Okay? So I'll just add this constant to the bx. This is the meaning of this. Then I'll go to that address. Now, without this displacement value, okay, going to other position, we'll call this indirect. This will be indirect. But when you add the plus 1, 2, 3, 4 hex, that means this is what, since I have base with a constant, that means this is a base addressing mode. Got the point? Now, if I ask you, how can I calculate the address of this, the physical address? Okay, assume ds, yeah, let's go. Assume ds is 0200, and in bx I have 100 plus 1234. How do I calculate this address? Yes, yes, okay. How can I calculate this address? This means what I'm going, any guess? I'll just add bx plus 1234. What is in bx? It's 100 plus 1234. Can you add it? Exactly. I'll just add, this is, will be the offset, the new offset, plus 1, 2, 3, 4 hex. In which segment? In data segment. Exactly, yes. So please don't confuse. It's like the indirect, but I have to use only two types of register, which are bx and bb, plus a constant value. Now let's do the same. How many bytes I'm taking for this? Let's follow it and execute. How many bytes I'm taking for this instruction? So the first, I'm going to the code segment. Okay, understand and do the translation to my to object codes. I have 4 bytes. Okay, right? See here, I have a constant in my instruction. It will be shown here. Can you see now Hissa and Hind and the others? Since I have a constant in my instruction, part of this is showing here. Can you see it? How can? Give me the physical address of this. It will be what? Bx. First, let's calculate the offset. Bx plus 1, 2, 3, 4. Bx. What is Bx plus 1, 2, 3, 4 hex? It's equal to 1000, right? Give me, calculate. Exactly. It's 2, 2, 3, 4. Because I add what's in Bx. Okay. Now, can I write this instruction in this format? Sure, I'll show it to you. Bx plus 1, 2, 3, 4 hex. Can I write it in this format? What do you think? Is that acceptable? Yes, it's acceptable. This is exactly the same of this. So if you see this, it's the same as this. Yes, Hamid, thank you. Now, what's the physical address? How do I execute the instruction? I know I need to go to the address. Okay, now I finished from the code segment. I got the number of the object codes, the number of bytes. How many cycles for this? Yes. So, yes. How many? Yes, I'll go to, what is the physical address? Give me the physical address. Now I need to execute. So this is the data segment, right? So I need to copy the value of AL to this memory location. What is that memory location? Give me the physical address of this. It will be DS. You add a 0, 0, 2, 0. You add a 0 here plus that number. It will be what? Yes, 0, 4. Yes, 2, 3, 4, which is here. Yeah, this part here. Now what do I need? I need to copy AL, the value of AL, to the destination of the memory, because now the memory is the destination. Be careful from this. Now we have to know the direction of the instruction. The destination is this part here. So what is NAL? AL is the lower part of AX. It's ED. So where do I save ED? It will be saved here or here? 3.4 or 3.5? Yes, lower part. So I'm going to have here ED as a content. This will be ED. But the points, without a constant, we cannot do this. We are merging, as Dr. Ali said, we are merging the indirect with the direct, because indirect I use constant. Clear, guys? Yeah, we get the total offset, then we calculate. Yes. Any question about the base? Tamam. Now, the second one, you will explain it to me. The second one called index addressing mode. Now here is the same thing, but the only different is the register that I'm going to use. In this addressing mode, I'm going to use another two types, which them SI and DI. These are the registers. Now, is it a must to add a displacement value? Yes, I have to add a displacement value. I have to add a relative. I have to add a constant. Otherwise, it's the same as the base. It will be considered as indirect. Okay, so the only difference between the index and the base is the registers. Here I'm using SI and DI. There I'm using what? BX and BB. تمام. Now let me show you the example here. Now what's the difference here? How many bytes I'm taking? Let's see, Dr. Ali saying. Yes, yes, doctor. So as Dr. Ali said that exactly the same as the base, the only difference is the register that I'm using. In index, I'm using SI and DI. So you follow the same step. We go to the code segment, we check the object code, and now check here. Since I have a constant, the constant part will be shown in my object codes. Can you see this? I have 3.4, 3.4 is here. I have 1.2, 1.2 is here. Now then I need to calculate the total offset. What is the total offset? It's what? It's equal to what based on this example? I need to add. Yes, yeah, Tamara. Yes, Maha. Yes, Hind, you're right. So I'll just add what's saved in SI, which is 2, 3 zeros plus 1, 2, 3, 4. It will be what? Now, remember I need to go to the data segment. So what is the physical address for this? Do I go to this address to get the content, or this, or this, or this? Give me the physical address. I'll give you time. Did you calculate? Yes, exactly. Exactly, Maha. Exactly, Sheikha. Yes, Hind. Sarah. Yes, sir. Yes. So I calculate the physical address, which is here. Now, what do I have to do with this value? Now, where is my destination? What is my destination in the system? The destination is AL. Remember this part, this open the source and this. So I'll go to AL and change this to BE. Tamam. Yes. Good. So this is for index. The question, if I wrote the instruction in this, move AL, comma, SI. What is that? Sorry. What is the type of this? What's the addressing mode used here? Yes. So here we are merging. Yes. Thank you. So just be careful. I'm focusing on this just to be careful. Now the last one is the base index addressing mode. Now here is like hybrid between the base and the index. Here I can use both. base, once you see one of the base register with one of the index register, for execution, I'm reading 1 byte or 2 byte. Yeah, we talk about this too. Yeah. Dr. Ali is asking for, I'm reading 1 byte or 2 bytes. Okay, what is it? Yeah. Here, do I read from the memory 1 byte or 2 bytes? As I said, it depends on the size of the register here. If it's 1 byte, you just take 1 byte. If it's 2 bytes, you take 2 bytes. Yes, doctor. Yeah, it's 1 byte only. 1 byte I'm reading, doctor. It's AL, yeah. AL 1 byte, I'm getting 1 byte. Yes, Hamad. It's AL, not AX. Yes. Yeah, we'll talk about this, doctor. Yeah. So if I change now this AL to AX, that means I'm taking how many bytes? So it depends on the size of the register. 1 byte, you take only 1 byte. 2 bytes, you take 2 bytes. Clear this point? Is it clear, guys, this point? That is 1 byte. I'm sorry, I missed my connection. Can you hear me now? is my voice is clear now? Thank you. Yes. Sorry, I had a problem with the internet. So, thank you. So please go through the slides again, Dr. Ali's slide, and in case you have any question, yeah, please let me know. Yeah, it is 10:50, دكتور. دكتور شكلهم حابين يضلوا دكتور. Thank you, Dr. Ali.